Finding the value of A and B in a recurrence relation. The national 5 essential skill required for this is simultaneous equations. If we know that a sequence is defined by a linear recurrence relation of the form un plus 1 equals aun plus b, and we know 3 consecutive terms of the sequence, then we can find the values of a and b. This can be done easily by forming 2 equations and then solving them simultaneously. Example 1. The first 3 terms of the linear recurrence relation un plus 1 equals aun plus b are 2, 4 and 14 respectively. Find the values of a and b. So to start with, to get u2, we would have multiplied u1 with a and then added on b. We are now going to sub in u2 and u1. So 4, which is u2, is equal to 2a plus b. Again, u3, to get this value, we would have multiplied a with u2 plus b. So subbing in the value of u3 and u2, we get the equation 14 equals 4a plus b. We now have 2 equations which we can solve simultaneously. Here we have 1b and 1b, so we're going to subtract. 2a take away 4a is negative 2a. Our b's will cancel each other out, and 4 subtract 14 is minus 10. Dividing minus 10 by negative 2, a has a value of 5. We'll then sub a equals to 5 into one of the equations. 2a plus b equals 4. So 2 times 5 is 10. So 10 plus b equals 4. This rearranges to give b equal to minus 6. Therefore, a is 5 and b is minus 6. Example 2. A sequence is defined by un plus 1 equals aun plus b with u1 equaling 4, u2 equals 3.6 and u3 equals 2.04. We have to find the values of a and b. As long as we have 3 consecutive terms, it doesn't matter what 3 consecutive terms we have in the sequence. u1, u2, u3 are all one after each other. Therefore, to get the value of u2, that would be a times u1 plus b. Subbing the values of u2 and u1 in, we obtain 3.6 equals 4a plus b. And again, u3 equals au2 plus b, and we're going to sub the value for u3 and u2 into the equation, and we get 2.04 equals 3.6a plus b. Again, we need to solve these simultaneously, so lining them up, we have 4a plus b equals 3.6, 3.6a plus b equals 2.04, and again we have to subtract to eliminate our b's. 4a take away 3.6a will leave us with 0.4a. 3.6 subtract 2.04 equals 1.56. If we then divide 1.56 by 0.4, a comes out as 3.9. We're then going to sub the value of a into 4a plus b equals 3.6. Therefore, 4 times 3.9 is 15.6 plus b is 3.6, and this rearranges to give b equal to negative 12. 3.6 take away 15.6 will give us negative 12. So a equals 3.9 and b equals negative 12. Now try this example on your own. Please pause the video. The answers: A, P equals 4 and Q equals minus 10. And for part B, U3 equals negative 18. Please self-assess your progress. So what have we learned today? To find the value of A and B of a recurrence relation, we need to follow some key steps. Step 1, we use consecutive terms to form two equations. Step 2, we solve the equations simultaneously. And step 3, we clearly state the values of A and B in our final answer.